Hello everybody, I'm the French scientist, and today we're going to talk about exponential growth. But first, let me ask you a question. Would you rather have $10 million right now, or the sum of a penny doubled every day for a month? In other words, you will get 1 penny, 1 cent today, then tomorrow you get 2 pennies, 4 pennies, the day after that, etc., etc. In other words, the real question becomes, after 30 days, will you get in total more or less than $10 million? Another way to look at it is to maybe start with smaller numbers. For example, how long will it take me to get $1 in total? So I can do the math pretty easily when it's, those small numbers. I get 1 penny on the first day, plus 2 pennies, that's 3 pennies after 2 days. Then I get 4 pennies, so that's 7 after 3 days, etc. But to make our life easier, in this video, I'm going to use an Excel spreadsheet. And the reason for that is that it allows us to visualize all these numbers in a significant, meaningful way. And I encourage you to pause the video right now, open an Excel spreadsheet, and do the calculations I will do at the same time as me. So, on this Excel spreadsheet, in the first column, I will write down the day number. So it will be day 1, day 2, and I can just copy those to automatically fill in until day 30. This is after D-Day. So D1 is after D-Days 0, right? It's my first day, so it's 0, then 1, etc., etc. And I can just double click here, and it will automatically fill in the rest. Okay, now this is what's interesting, the daily amount of dollars we will get here, and in this column is the sum of all those days. So on the first day I told you I will get 1 cent. Then how do I find out how much I gain? On the second day I told you it's twice this amount. So it's equal to this value times 2. And to find out the rest, I don't have to write this formula again and again. I can simply here double click and it automatically fills in. And what you can see right now is that the total in 30 days that we'll get is definitely a bit more than $10 million. So long story short, this strategy is actually better. Now, you can see those numbers and they may be difficult to really interpret. What we can see, for example, is that it takes us more than 17 days to get every day more than $1,000. But then, after that, things jump pretty quickly. And that's the definition of an exponential. What you may notice also is that because every day we gain twice as much as the previous day, what we gained on the last day corresponds to half of the total. That's pretty important because in this situation that means the next day I will get 2 times what I earned here. Like I said, we can also plot this with a graph to visualize the growth. And we can see this characteristic feature of exponentials, that for a long time it seems that nothing really changes. But then, all of a sudden, everything grows very rapidly. But actually, in this situation, that's a trick from the scale here. So what if I change this scale and I just want to look at the data between 0 and say $2,000? Well, you can see that in this situation the growth is the same. But we did not see this change before because the scale was much larger. We kind of zoomed in here. Okay, so if I go back to the normal size, this is what it looks like. So the exponential growth is actually happening at all the scales in some sense. Exponential growth is actually kind of counterintuitive for our human brains. We are mostly used to think in linear terms. So for example, if I told you you will get 1 penny today and another penny tomorrow and another one the day after that, you would certainly just make a quick calculation. Okay, 30 days times 30 pennies, well, I will get 30 pennies at the end of the month. So definitely not enough, and I will take the $10 million and thank you. Now, here is the trick, because linear growth is represented by equations of the type y equal c times x. So a variable is a function of another variable times a constant. Now, exponential growth is represented by y equal y0 times c to the power of x, where y0 represents the initial state, c is a constant called the growth rate, and x is simply the time, in our case, the day number. So in our previous example, the equation would simply be y equal 0.01 times 2 to the power of x. For example, if I want to find out how much money I will have after 30 days, I can simply do y equals 0.01 times 2 to the power of 30. And actually, I'm going to show you on Excel that doing this calculation gives us exactly the same results as doubling the sum every day. So on the Excel spreadsheet, I can create another column with, again, the daily amount of dollars, but this time using the formula, the general formula. So this time it will be equal to y0, which is the initial value, so 0.01 times 2 to the power of this number. And the reason is that it's not the day number, but it's after how many days, what will you get. So after 0 days, today I get this value. Now if I copy, after 2 days I found again this value, and if we break down the equation, actually you see that it's 2 to the power of 1, which is 2, and it's 2 times 0.01. And we can copy the formula, and you see that we found exactly the same numbers. So I want to emphasize something about the constant rate, this variable c. In our example here, it's equal to 2, but it's actually maybe better to see it as 1 plus 1. I'm going to explain it. The reason is that it's 1 plus a proportion of the previous value. In that case, it's 100%. Okay, we are doubling every time. So we're taking what we had before and we're adding another 100% of what we had before. Okay, if we were to add only 50%, the variable would be equal to 1 plus 0.5. So 1.5. Okay. If we were to triple the value, instead of doubling it, it will be equal to 3, which will be 1 plus 2. We take the previous value, we had 200% of the previous value, which is 3. And this point is important to understand. Now, like I mentioned before, exponential growth actually never exists in real life, in nature. Why? Because there are always some limiting factors. In the example here, it may simply be the total amount of money available in the world. And it's easy to imagine at some point there won't be enough money in the world to give you, right?